Okay, everyone, welcome back to Bacon Magang. Stay humble and keep the excitement to learn like a newbie intern. As usual, before we start, I would like to thank you to all of you for supporting me by subscribe, like, and share. And for today, we will talk about the memory leaks. Memory leaks are like a ninjas, silent but deadly. And many developers say memory leak like a ghost. So you don't see them, but they haunt your performance benchmark. And do you ever felt like your app is bleeding memory? That's not just you; it's probably your code. So today we are diving into one of the simplest yet most effective tricks in Golang to patch up those memory leaks and to turbocharge your performance. It's small, it's sneaky, and it makes a huge difference. So without further ado, let's get it on.
Please like, share, comment, and subscribe.
When we talk about the APIs and memory leaks, think of your API servers as a restaurant. Every request is a customer, and your server is the chef. If you don't reuse your utensil, you will run out of clean ones pretty fast, and your server gets slow, and your customer leave hungry. It's not good, right? Let's jump to the code. I have a simple program to demonstrate it. Here we are. This is just a simple program, so I just have main.go only. In this program, I have two endpoints, the leaky one here and the optimized one. Okay. So the leaky one we'll call the leaky handler, which is yeah it does the job but not efficiently. So every time a request comes in, it creates a shiny new buffer but never bother to clean up or reuse it. We will see what happens when we hit this endpoint a few hundred times. Okay. Perhaps I have to run this program first. Okay. I think the terminal must be larger so you all can see what happened. And I will open the new terminal. So I will do some load testing, and because I use Mac OS, the Mac OS have Apache Benchmark as a default embedded software. But if you don't have Apache Benchmark, you can install it manually, or even you can use another load testing tool. It will give the same result. Like I told before, I use Apache Benchmark, so I will write a comment like this: ab this and 500, perhaps 500 dash c 50, and endpoint tp localhost http leaky data test, like this. What is this? So the AB, this is the Apache benchmark, the friendly tool we are using to perform a load testing. Think of it as your app's personal fitness trainer. It will pushing it to its limit to see how much it can handle. And the dash N500, this tells Apache Bench to send 500 requests to your endpoint. So in real life, this could represent traffic from hundreds of users visiting your app. And the dash C50, here's where things get spicy. The dash C option means we will send 50 requests at the same time. So imagine 50 people are trying to order a coffee at the same counter. How fast can your server keep up without spilling the coffee? So this is the command, and I will do the load testing. Yeah, as you can see, when we simulate 500 concurrent user, the things start to fall apart. Yeah, we will check the memory usage and the response time. Okay, before that I will copy this result. Like this. So I think this is the important part: the file request, the compute request, total transfer, HTML transfer, RPS, time per request, and yeah, the last but not least, the transfer rate. So I copy this first. Yeah, perhaps I will put it down here. Now I will move to the second API, the optimize. So the optimize is using sync pool. So the change is minimal, just a few lines of code, but you will look at the difference in performance. So this is the optimize. This is the leaky handler, and this is the optimize handler. I just give a small difference. So I call the process load data function, and in process load data function I use the sync pool, so buffer pool, sync pool. So the line 11 until line 27. So this is will process with the optimized memory. Okay, I will hit this endpoint using the Apache benchmark once again. We'll clear the terminal first. So like before, but now to the optimized endpoint. So AB -n 500 -c 50 and HTTP localhost 660 optimize data test. So yep, I will run it. Boom. So sorry, I forgot the okay, boom. And I will copy the result to the top. Okay, wait, I forgot copy the first one, but the completed request. Okay, it's okay. Okay, yeah, now we can compare the result. So the first one, we will talk about the request per second. This is 9,000, and this is 12,000, blah blah blah. So yeah, it's more than 10% different. So we can make a conclusion. The Optimus endpoint handle about 3,000 more requests per second compared to the leaky one. This means the server with sync pools or optimization is better at managing memory and resource, so enabling it to process more requests in the same time frame. And for the time per request, okay, this is 5 millisecond, and this is 4 millisecond. So on average, its request in the optimized endpoint take 5 millisecond, and yeah, while in the leaky endpoint it's slightly slower, right? So the improvement took small scale significantly in high load scenarios. And the last one is the transfer rate. Okay, so the transfer rate of the optimized endpoint is see the difference 1300, and this is 1800. uh yeah, this show better resource utilization and faster data handling in the optimized version. Wait, the connection time. Yeah, it give the big difference also in the connection time, but I forgot to copy from the leaky one, but it's okay. So from the total transfer, request per second, and the transfer rates, you can see the huge difference from the leaky one, so the leaky one and the optimized one. So the leaky endpoint perform reasonably, but yeah, suffer from a lack of efficient memory management. So the overtime in real world production system, the impact of memory leaks would increase, leading to degrade performance or even crashes under the sustained load. And for the optimized one, by using simple the optimized endpoint avoid memory leaks and reuse resource efficiently. The result in better throughput, more requests per second, of course, and faster average response time and higher consistency in request handling. And why it matters. So, okay, while the difference in performance might seem minor for this small scale test, yeah, this is just a small demonstration. But in a production environment with a million requests, and yeah, the optimization will translate into fewer server crashes or restart due to memory exhaustion and lower infrastructure cost, of course, as you can handle more traffic with the same resource. It will, yeah, lower infrastructure cost, and of course happier user with faster response time. So yeah, this is just a small example, but in real world application, this technique can be used to manage the HTTP connection, database connection, or even caching. Of course, in production, you will integrate advanced tools like Redis or, yeah, some specialist pooling library for even better performance. So the conclusion is, well, with just one tweak, we went from leaking memory to handling requests like a pro. Small tweaks, big impact, and yeah, it's the developer way of saving the world one byte at a time. Now, go test this out and impress your team, or even impress your boss. Okay, I think that's it, folks. Yeah, a tiny tweak with simple, and suddenly your app stops bleeding memory like a sieve. And yeah, remember, memory leaks might not scream at you right away, but they sure will haunt you in production if left unchecked. So small changes like this make a big difference in performance, scalability, and let's be honest, your sanity as an engineer. And yeah, the devil is in detail. The small tweak not only boosts your app efficiency, but also, yeah, future proof it against scaling issues. It's clear example of how small changes can lead to a big impact. So will yeah, I will make you remember this is just a small change, but make a huge impact. Yeah, now you can imagine the nightmare of memory leaks haunting your production server gone. And all thanks to this optimization. And yeah, if you found this helpful, or yeah, even just a little entertaining, don't forget to smash that like button and subscribe to my channel for more backend tips, tricks, and deep dive like this. Your support keeps me going and help us grow this amazing community of learners. So as always, stay humble, keep learning, and I'll see you in the next one. Cheers, backend maga.